this was a team effort and not a single man's effort. And I thank all of them. I especially thank the project sponsors, CPWD, and then especially the Department of Science and Technology, DST, at the time, TIFAC was the nodal agency for that, and Dr. Vimal Kumar Ji, so who has also now retired. And it was a collective kind of efforts with my HODs and directors, Professor D.V. Singh, who is no more, Mr. AVSR Murthy, who is also unfortunately not with us anymore. And so this work was taken up, and it was successfully completed. And the output was that the fly ash, which was a kind of a new material, which was a kind of a unknown material for the civil engineers, it has now been accepted as a standard material. Similar to soil, material similar to muram, etc. for road works. So that is the outcome of that. And as Professor Agarwal ji already pointed out, the using this material is a sustainable construction technique, sustainable way of building our roads. How, you may ask? Because the very definition of sustainable construction, it says that whatever the waste materials that are resulting from one process, they are used as a raw material in another process, and so that this cycle chain continues, so that there is no net waste material production, and the need for the new raw materials is minimized. So, in the same techniques have been adopted in using this fly ash also in the road works, because the fly ash is considered as a waste material produced by the thermal power stations, and that becomes a raw material for the construction of our roads, maybe the embankment, maybe the road pavement, like that. And when it becomes the raw material, it replaces the conventional raw materials which are being used, like wood earth, or maybe the aggregates. So this kind of material are replaced. So that is why it is an ideal type of sustainable construction technique. So now let us, of course, move to my PowerPoint presentation. I will share my PowerPoint presentation.
Of course, the Vittal sir talked about Dr. Vimal Kumar ji. He is the key person who collected everybody, and he used to collect, and he is a pioneering. He does pioneering work in through typeface. Yes, sir. It is visible, sir. Your presentation.
Yeah. Now it is, I think, full screen.
Yes, sir. It is full screen, sir.
Full screen. So my topic, as I have already pointed out, it will be use of fly ash in road construction work. And presently I'm working as a chief scientist in Central Road Research Institute. My email and mobile numbers are given there for you. If anyone of you wants to contact me with regard to any aspect related to my presentation or using fly ash, etc. Okay. Now I have changed the slide. I think my slides are changing.
Yes, sir. It is changing, sir.
Okay. Okay.
It is changing, sir.
Okay. 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 So to begin with, type of coal ashes are the types of ashes which are produced in a thermal power plant. Mainly this this powdered coal is burnt in a thermal power plant in the furnace to produce steam, and the steam from using the steam we run our turbines and produce electricity. But there is one part for the electrical engineers to look into. But for us, for civil engineers and highway engineers, whatever the coal, powdered coal that burns in the furnace, so that burns in the furnace, so it produces the ash. There will be two types of ashes, and which you would be aware, and one is the 80% is the fly ash, the fine material, which is about 80%, and that fine material goes along with that goes along with the flue gases, and of course we cannot leave it into the atmosphere. If we leave it into the atmosphere, then so much of pollution and nuisance will be there. So that is why that whatever the fine particles of fly ash are there, they are collected using the electrostatic precipitators, and whenever the fine particles are, whatever fine particles are there, due to colloidal chemistry, you would in colloidal chemistry you would have studied, they are electrically charged. So as long as they are electrically charged, they keep on repelling each other. So when they were passed through a electrified field in the ESP, they lose their charge and they are collected in the bottom of the ESP, and from there using suction they can be taken out. And about 20% of that ash particles, they sinter, means flocculate together, adhere together, and become bigger particles, and fall down to the bottom of the furnace, and from there it can be removed, and both the fly ash and bottom ash, they are mixed with water and pumped into the ash ponds, and that becomes the pond ash. Of course, the usage where this fly ash, bottom ash, and the pond ash, they are used, ideal usages, they are different. The fly ash will be a reactive type of material, so it is used in cement concrete and replacement of cement, roller compacted concrete pavement, etc. And this bottom ash and pond ash, which are not reactive, they are used as the fill material, and they can be used in agricultural application. Also, they can be used for road pavements in the form of stabilization also. Now, in some of the plants, this mound ash is there, and that means actually this whatever the total fly ash and bottom ash is there, it is not mixed with water in a big quantity, but as a paste, it is collected, so that becomes that is known as the mound ash. Pulverized fly ash is nothing but the coal ash only, and that's the term which they use it in the BIS, Bureau of Indian Standard Codes. Now, this, of course, I will be using, as I pointed out in this previous slide, I will be using the fly ash as the common name or the generic name for any type of coal ash. But normally, for my works, I will be using pond ash. For my road works, embankment work, etc., I will be using the pond ash. Whenever there is a need to use fly ash, I will be specifically telling you that dry fly ash is to be used. So using fly ash in our road works, it can be in 3 different forms. It can be for our embankments and backfills in the road structure. It can be used as in the form of stabilized layer. And when we construct a stabilized layer, that will be to improve a subgrade. That may be to construct a sub-base layer and the base course layer. And we can use the fly ash in the form of a cement replacement agent in a concrete pavement or for paver blocks, self-filled concrete, kadanja, etc. Okay. So this fly ash properties vary to be characterized before use. That is nothing special. Actually, properties of all construction materials vary. Soil also, aggregates also. What do we do? We test the material, and accordingly we design our structures. So in the similar manner, fly ash properties will also vary. Whatever the fly ash you will get in Kota will be entirely different from whatever the fly ash you will get in Suratgarh, because in Suratgarh it is lignitic fly ash. Whereas in Kota, as I understand it, they don't use the lignitic fly ash, so the properties will be entirely different. So we have to test the material, and accordingly it has to be used. Major constituents of the fly ash are the oxides of silica, aluminum, iron, calcium, magnesium, similar to soil. And it's environmentally safe material for the road works. Even in the advanced countries also, like USA, etc., they consider this fly ash as an environmentally safe material as far as road works are concerned. We have been taking up this road works using fly ash since more than 2 decades, almost or 25 years are over, and so that's why no adverse reports have come, and so that's why it's an environmentally safe material. Definitely, we can say, and possesses many favorable properties for the embankment and road construction. I will tell you in the coming slides. And the usage is mandated by the Government of India. Government of India, where long back, before more than 20 years back, it has brought out the gazette notification. Afterwards, there have been regular updating of this gazette notification also. So the gazette notification mandates the that means makes it compulsory for road works and building works, etc., nearer to a thermal power station to make use of the fly ash. This is the MORTH notification. It was brought in the year way back in 2003, and of course afterwards also they have given time and again they have given other OEMs also, and making it compulsory, taking the attention of the PAUs to the gazette notification to use the fly ash in their road works. This is the OEM from the NRIDA, National Rural Infrastructure Development Agency, who take up this work with regard to this rural roads. And of course, they have brought out this kind of a some, useful handbooks also, and do it yourself. Means a PAU can construct the road using fly ash on their own, referring to this whatever the guidelines and instructions are there in this kind of a booklet. So that where we can get the booklet, that also that link I have given. And so the point I want to make is that both highways, that is MORTH, which is responsible, rural roads for which MORD and NRID is responsible, they are keen on using fly ash. What are the favorable properties for the fly ash in road construction? First and foremost is that it is a lightweight material compared to commonly used fill material like soil, and so it will cause lesser settlements. So suppose we are constructing an embankment over a clay type of soil, BC soil, etc., like that, and over that, if we build our road embankments, definitely with the time there will be settlements. So if we construct an embankment using fly ash in such areas, such subsoil areas, and then the net result will be actually this is a lightweight material, means the density will be lesser, so it will be exerting lesser pressure on the subsoil, and which will lead to lower settlements. So that is why this is an ideal kind of a material for clay type of soils, wherever the subsoils are clay. And usually pond ash and bottom ash have higher California bearing ratio as compared to soil, which can lead to lesser pavement thickness. This pond ash and bottom ash are coarser in nature, and the particles are coarser. So that is why they will be having a higher CBR value. If they are having higher CBR value, means lesser pavement thickness. Pozzolanic hardening property imparts additional strength to road pavements and embankments. Pozzolanic hardening, we mean that something which in the presence of water and lime, it hardens. So then there's something similar to surki. So the brickbats are there. To that we add some lime, we add water, we compact it, it hardens. So in a similar manner, fly ash also, of course, if we add some lime or if we add some cement and some water, it hardens. So this property is called pozzolanic hardening. In this lignitic fly ashes, they already contain some lime, higher amount of lime compared to the anthracitic fly ashes. So that means the fly ash in Suratkar and nearer to Bikaner, whatever we find is a lignitic coal. So that kind of ashes, if we add water, there's no need to add any additional lime. It will harden. Of course, if you add additional lime, additional cement, also it will harden more. The strength development will be more. So this kind of a hardening of that material, if you use that material in the embankment or if you use it in the road pavement structure, so it's a kind of a stabilization reaction. So that's why it will add strength to the pavement. Amenable to the stabilization using cement and lime, this point I just told, can be compacted over a wide range of moisture content, therefore results in a lesser variation in density with changes in moisture content. This fly ash Actually, it is a non-plastic material. So it doesn't have any plasticity index. It's non-plastic. But the the manner in which it reacts when we compact it, it will be similar to clay type of soil. The clay type of soil, they don't have a sharp OMC-MDD curve. They are having a flat OMC-MDD curve. When we do the compaction test, Proctor compaction test, or standard Proctor or modified Proctor on a clay type of soil, we get a flat curve. So this kind of this fly ash also exhibits a similar nature, but it's non-plastic. So that is the beauty of that material. And this material which can be compacted when it's having a flat OMC-MDD curve, it can be compacted over a wide range of moisture content, which will not result in the very big changes in the MDD. Easy to handle and compact because the material is lightweight and there are no large lumps to be broken. It's already powdered material, and so that's why there is no need to break the lumps like unlike a clay type of soil. Can be compacted using either vibratory or static rollers. We can use both vibratory and static rollers. That's big plus points. Offers greater stability of slopes due to higher angle of friction. Phi value is more. When we do this direct shear test on this material, we get a higher phi value. So that is why we can have a steeper slope of the embankment. Considerably low compressibility results in negligible settlements over the within the fill after compaction. So that's also another important point. When we are constructing high embankments, of course, some inherent because of that compressibility of the material which has been used in embankment construction itself, so there will be some settlements. So that is very minimal in case of the fly ash because it's having a low compressibility. CC value will be very, very less. High permeability ensures free and efficient drainage after rainfall. The water gets drained out quickly, ensuring better workability than soil. This is especially during monsoon season, so we can the work can restart immediately or after within a few hours after rainfall, whereas the soil will require much longer time. So this is another important aspect of course, during monsoon season, it becomes more. This is important because in the monsoon season, when it rains, whatever the soil that has been spread out for compaction, it becomes slushy. So we will not be able to run our roller. We will have to wait for that soil to dry up. But that's not the problem in case of fly ash because it's having a very high permeability, just like sandy soil, just like a muram. So the sandy soil, even if more water has been added, what will happen? The water will, it's having a very high permeability, water will go out. So that's why we'll be able to compact the sandy soil and use it even after, immediately after rainfall also. Fly ash also behaves in a similar manner. Faster rate of consolidation, a major part of the volume decrease occurs during primary consolidation phase, similar to the last point I made in the previous slide. Conserves good earth and aggregates, thereby protecting the environment. So this is the first point which I told with regard to sustainable construction. So when we use fly ash for our roadworks, we conserve the soil, good earth, and we when we undertake embankment construction, and when we use it in pavement construction, we conserve aggregate resources. Of course, Rajasthan has been blessed with a very ample amount of aggregate resources, but of course, everything is finite. It is not infinite. So, if not today, maybe after a few decades, there will be scarcity of the aggregates. So this has already happened in the states which are all around Rajasthan, that you would have realized. Now the aggregates, there are no aggregates in Haryana, there are no aggregates in Punjab, there are no aggregates even in Western UP also. So all those areas, they are now getting aggregates from Rajasthan. So this even from Delhi also, the road making aggregates, they come from Rajasthan. So even though the state has been blessed with good resources, but we have to be prudent. We have to be conservative in our usage so that the coming generations They will be they will not be put into any hardship. That's the idea. Now, I have put this slide to compare the differences between Indian and whatever the fly ashes that are generated in Western countries. I have taken the US as the example, just to show how the properties vary. With regard to our fly ash and the fly ash produced in the USA. So this loss on ignition, we have a very low loss on ignition, whereas it is little bit higher because they don't burn it to a very high temperature to prevent SOx and NOx formation. But of course, unfortunately, that's not the case in India, and so very low LY is there. So that is a good point as far as we use it in our cement concrete works. And the SO3 content, sulfate content, that's a very big, very important issue. As far as this scrubber, sulfate scrubber is concerned, and acid rains are concerned, we are being blessed to have a type of coals which are very low in sulfate content. There, the sulfate content is more, but our coal is having a lower sulfate content. So that is why our fly ashes will also be having a lower sulfate content. That's a very good point. And the CaO content, the calcium oxide content is about 1 to 3%. There it is a mostly lignitic ashes, so that is why a higher content of CaO. And unfortunately, we don't clean our coal to a very big in a very efficient manner, and so that is why we end up with a huge amount of ash. There they clean the coal in a very efficient manner, so that's why the amount of ash produced is lower. Less than 15%, 20% like that. Whereas here it is 30 to 50%. Whatever the coal we burn, 30 to 50% of it we end up as ash. But the issue is that whatever may be the amount of coal that we are burning, the concentration of heavy metals will be similar. Whether we end up with 1 kg of fly ash or 10 kg of fly ashes, the total amount of heavy metals in the coal itself, in the source coal itself, is similar. So that is why what will happen, we are ending up with a higher quantity of ash. So the heavy metals are spread out through the total volume of our ash. So the concentration of the heavy metals is lesser when compared to the concentration of heavy metals in their coal ash. So that is why here it is only 3 to 4 times in comparison to source coal, whereas it has become 10 times in comparison to source coal. So what is the net result? So when it leaches out, means when the heavy metals come out along with water from the ash, eventually it may come out when it comes in contact with water. The toxicity of that toxicity of the leachate, the rate of leaching of the heavy metals will be lower in our case, whereas it is higher there because the concentration is more. So the leachate will be having a higher concentration of the heavy metal. The point I want to make here from this slide is that our coals are green coals. Our ash is a green ash. So if somebody is using an imported coal and like that, maybe he would be in an advantage to producing a lower amount of ash, but environmentally he will be degrading the environment in a much more severe manner compared to our coal. Now, using the ash as a geotechnical material for embankment construction, etc. So how we go ahead with that? So this slide I have put it to show the comparative properties of the fly ash along with 3 different types of soil particles, that is sand, silt and clay. For specific gravity is much lower for fly ash particles. Why the specific gravity will be lower? Because when the fly ash particles are formed, they may contain a air bubble inside. So that is why the specific gravity of the fly ash particles itself becomes lower when compared to specific gravity of the soil particles. Usually soil particles have a specific gravity of 2.65, 2.7, etc. If iron content is more, then it may even go to 2.8, 2.9 like that. But here, since because the air bubbles are there in many of the ash particles inside the particles, of course it's not open. It's entrapped inside the particle, so that's why the specific gravity is lower. Since the specific gravity is lower, the MDD, maximum dry density value, that also becomes lesser. Usually it will be about 1.1, 1.2, etc. This is a range I have put, but usually it will be about 1.1, 1.2, etc. And when the specific gravity is lower, usually the OMC will also be higher. And that is for the soil particles also, and in a manner, similar manner for the fly ash also. But the point here is that we will be using pond ash for our embankment construction. So the pond ash will be taken from the ash ponds where the bottom ash and fly ash are there, are mixed along with water. So some amount of moisture will already be there in the pond ash. So the net amount of moisture that is to be added before their compaction will be lesser. Even though this may look 38% is very high, it will be having about 20-25% moisture already. So if it is having about 25% moisture, the net amount of moisture that is to be added is only 13%. So normally this OMC range will be around 20-25%, and this will be around 1.1, 1.2, etc. And so this point also I have already told you that the angle of internal friction phi value will be much higher for this fly ash particle. That means the pond ash and the bottom ash particles when compared with the this soil particles. Of course, it's a comparison we can make it along with the sand size particles. But the issue is that you see the particle size range. Normal, it may be either a majority of the particles may be silt size particles or the sand size particles in the fly ash. Normally, if it is a very coarse size, coarse type of fly ash like bottom ash, the sand size particles will be in more concentration. And if it is a fly ash is in excess, fly ash is more, it will be silt size particles. Whether it is silt size or sand size, these phi values and all, it will be within this kind of a range, phi value, MDD value, etc. Now, using the fly ash in the embankment construction, how do we use that? Actually, when we started using fly ash of this material, we use either the bottom ash or the pond ash for the embankment construction. This point already I told you. And this material, I told you, it is a non-plastic material. And as you saw from this, it's a non-cohesive material also. Cohesive is negligible, I have written. It will be almost zero. So it is a non-cohesive material also. So if it is a non-cohesive material, and if I make an embankment using a non-cohesive material, when it rains, it will erode. The rain water will erode a non-cohesive material. So that is why this concept of using fly ash encased between this good earth cover, it was evolved. So this was the idea. So we cannot use a non-cohesive material in an embankment construction open to the atmosphere. If we use it in open to the atmosphere, because of rains and even because of wind also, it will get eroded. And once it starts eroding, it may fail, the embankment may fail. So that is why we use it in the core of the embankment, in the center of the embankment, and we cover that core of the fly ash or that is the bottom ash or the pond ash with a earth cover. How much thickness of this earth cover should be, that I will show you in the coming slides. That has to be properly designed. And this earth cover will be on the sides also. It will be on the top also. And this is the guideline which was formulated, IRCSP 58, guidelines for the use of fly ash in road embankment. And even the more Ministry of Rural Development specifications also, which has been brought out in 2014, they revised it. 2004, it was brought out in the first time, and 2014 they revised it. It has a separate clause 306 for embankment construction. Now, some salient points which I have taken from IRCSP 58, I have put it here. The design considerations are similar to the earthen embankment. That means whatever the stability analysis we make, slip circle method, etc. So that is entirely similar to for a fly ash embankment design, it's entirely similar to the earthen embankment. So whatever the softwares we use, maybe the Geo4, maybe any other software, the same softwares can be used and for designing the fly ash embankments also. Only the issue is that the fly ash embankment will have to be used in the core of the fly ash material will have to be used in the core of the embankment and provided with a earth cover. The factor of safety, how much we should aim, it should be about 1.25 in the normal conditions and the minimum 1 under seismic and saturated conditions. And then the density of compacted fly ash should be considerably lower than soil. Fly ash with low MDD value should not be rejected. Okay, ash has no cohesion. The C value is 0, and phi value should be the basis of the design. Whatever the phi value we obtain using a direct shear test or a triaxial shear test, so that can be used for our design purposes. Very little possibility of liquefaction of fly ash. So this is another important point. Actually, what is liquefaction? Liquefaction is that when a material, fill material loses its entire shear strength and behaves like a liquid, that is called liquefaction. So when this liquefaction will occur, liquefaction usually occurs when there is a earthquake. So when there is an earthquake, vibrations are there and earthquake forces are there. So the material which is in loose state, soil material which is in loose state and which is saturated, which is having water in its voids, it liquefies. So this liquefaction during an earthquake we can see in very fine sands and we can see it in silty soils also. This fly ash is having a particle size similar to silt, particle size similar to sand, I told you. So this material will it liquefy, but an embankment constructed using a fly ash will not liquefy. That is because for the liquefaction to occur, I told you the different conditions which are to be satisfied. First one, of course, it has to be a silt size material. Fly ash, of course, it may be a silt size material that is there. But the next condition, it has to be in loose state. The material should not be compacted. If it is compacted, the liquefaction will not occur. So we compact the fly ash to a high degree during our embankment construction. So the liquefaction chances are reduced. Third is that the material should be saturated. Whatever the silt material is there, whatever the sand material, fine sand material is there, that should be saturated. And since we are constructing an embankment covering with earth cover also, there is very little chance of water going inside and saturating the embankment like that. So that is why the third requirement also is not fulfilled. So that is why there is very little possibility of liquefaction of fly ash embankment. I have put it here. The Indian fly ashes have lower SO3 value and lesser heavy metal content. This point already I told you. Earth cover to prevent the erosion and water ingress. And that diagram also I have showed you. How much should be the thickness of the earth cover as per the ARC specification? The earth cover should be about 1 meter for an embankment height up to 3 meters, and the cover can be increased for the higher heights, and the maximum up to 3 meters. Usually for a very high embankments like 6 meter, 7 meter, 8 meter high embankments, we provide an earth cover of about 2 meters. Then the intermediate soil layer, if the embankment height is more than 3 meters. So what is this intermediate soil layer? I will show you in the coming slide. Minimum thickness of the intermediate soil layer 200 mm. Okay, embankment construction is similar to the earthen embankment. The methodology is similar. Loose layer thickness can be up to 400 mm if the vibratory roller is used. Loose layer thickness can be 200 mm if a static roller is used. So by using a vibratory roller, we can increase the loose layer thickness up to 400 mm. Normally about 100 mm thickness, when it is compacted, it becomes about 60 mm compacted layer thickness. So the 400 mm layer, if it is compacted, it becomes around 240, means 24 centimeter thick layer. So that is another advantage. Means this material can be compacted easily. Soil cover and ash are to be compacted simultaneously. That means when we construct an embankment layer by layer, we have to lay this earth cover as well as ash layer, and then this side earth cover also simultaneously, and then compact it. So when we start the compaction, we start from the edge, go to the center, Start from the edge, go to the center. So during the construction, this compaction of the earth cover and this ash, they go hand in hand simultaneously. It is not that first we compact this and then we go on constructing or compacting this layer. So that's not allowed. As per the MORD specification, what are the highlights, important points, and the flash embankments to have appropriate side cover? Okay, at that I have already told you. Flash shall cover all types of coal ashes. Okay. Test results for the engineer approval, what is to be given, particle size analysis and standard Proctor compaction test. This is for the rural road, MORD specification. So that is why the standard Proctor compaction has come. Otherwise, for the highway works, we go for the modified Proctor compaction. Material for the side cover to conform to the section 301, that is normal soil which can be used for embankment construction. It can be used in the flash embankment also as a cover material. Loose layer thickness, once again here also 200 mm and 400 mm, depending upon the type of the roller. Embankment to be compacted to 98% of the MDD. Okay. Top of the embankment to be covered by about 500 mm thick earth cover. Not only the sides, the top also to be covered with an earth cover, and side earth cover can be about 300 mm and maybe up to for the rural roads. Okay. And this is as per the technology initiative guidelines. Okay. You remember this one. Actually, here it is 300 mm for the rural roads, because the rural road, the height of the embankment is lesser. So that is why the side earth cover requirement is also lower. Whereas in case of highway works, the height of the embankment is more. So the earth cover thickness is whatever that has been proposed is also more. Because higher the embankment height, more will be the runoff water that will be accumulating. So that is why the to prevent the runoff accumulated rainwater eroding the embankment surface, we have to increase the thickness of the cover. Flash embankment should be measured separately for soils and flash. That is for the estimation purposes. Now coming to some case studies, this was a very old case. This is a very old case study in 1998, and the first case of embankment constructed without reinforcement using a fly ash, and that was done in Delhi only, nearer to our office, CRRI. And at the time, there was already one bridge was there in near the Nizamuddin railway station that they used to call it as Nizamuddin Bridge over the Yamuna River. And the Delhi PWD took up construction of a parallel another bridge also. So then they took up the bridge construction. Of course, the bridge requires the approach embankments. These approach embankments were constructed using fly ash. The embankment, of course, not both the approaches. The approach which was longer, that is about 1.8 kilometer length. So that approach was constructed using fly ash. The another one which was around hardly some 300 or 400 meters. So that was constructed using soil only. So that's why I have written embankment length about 1.8 kilometer. Height varied from about 6 to 9 meter. And this much 1.5 lakh cubic meters of ash was used, and it was located in the flood prone area, Yamuna river basin. So every year when there is flood in the Yamuna river, the water spreads out, and in the same flood prone area, this embankment was constructed. So that's why at that time the people expressed their apprehensions that okay, if it floods are there, how with this embankment will behave, and this is a very lightweight material, will it not float on water? So even that kind of questions were raised. But of course, it's a lightweight material, 1.1, 1.2 gram per cc. But this is MDD. This is not specific gravity. Specific gravity is much more than 1. So that is why it will not float on water. It will stay there. So these points were made, and then there was no availability of performance data, etc. The design procedure was also very new. The manner in which the embankment is to be constructed, that was also unknown. So all these points were there. Of course, they were tackled slowly one by one. We did the instrumentation also, some in that embankment to find out how it is performing. And of course, by using fly ash, Delhi PWD saved a lot, 1 crore rupees. It was a lot of money in those times, and of course, That's mainly because if they had to use soil, the soil had to be brought from very long distance, maybe from UP, maybe from Rajasthan, also like that. And so because in Delhi itself, they were not getting any soil, and digging soil in Delhi was banned already. So that's why all this, whatever the problems are there, they were solved in one stroke by using the ash which was available readily next door, almost you can say, within Delhi itself. So this was the type of the cross section of the embankment which was designed, and you can see this is the side cover. Already one existing embankment was there. You can see the existing embankment here. You can see the existing embankment here. So that's why this side there is no cover or anything. The existing embankment itself will act as the cover, and the side soil cover was provided on one side. Then that side you can see, and it was 2 meter thick earth cover. Okay, so these are the intermediate soil layer which I mentioned before. These are the intermediate soil layer. So they have been provided at a distance of every 2 meters. So what does this intermediate soil layer is for? Actually, this pond ash or the fly ash, whatever the coal ash which we are using for this embankment construction, I told you it is a cohesionless material. C value is 0. So whenever we use a cohesionless material, if it's a having a C value 0, so it has to be confined. Otherwise, it will not develop its shear strength. So just like sand is also, until and unless we confine the sand, it's very difficult to derive any shear strength out of soil, out of sand. So in the similar manner, these ash particles also, their C value is 0, so it has to be confined. So this kind of a confinement on the sides is provided by this side soil cover. This side, of course, once again the cover, but the confinement on the top is provided by this intermediate soil. So this particular cell of pond ash is now very well confined. So that means it will develop its shear strength potential. The another advantage is that, okay, this is about a 1.8 kilometer long embankment, 6 to 8 meter high embankment, and so it cannot be constructed within a fortnight. It cannot be constructed within a month like that. So it has to be constructed over a period of time, 6 months, 8 months like that. It was like that. It was constructed like that only. So during these 6 months, anytime it may rain. So even during summer also, even during winter also, sometimes it rains. Not only the rainy season. So let us say we have come up to this stage, and all of a sudden it rains. What will happen? This entire embankment, it will be under the mercy of rains. It will be eroded. So, but if we have provided an intermediate soil layer, let us say we have already provided this layer. So we are at this level, it rains. Then that means the rain will damage only the top 1 or 2 layers. It will not damage below. So the extent of the damage due to the rains will be limited. So that is another advantage. So because of these two advantages, one is the confinement, and the second is during construction, if it rains, to take care of the erosion. So this intermediate soil layer is useful. So this intermediate soil layer usually we provide, the height of the embankment is more than 3 meters. If it is less than 3 meters, there is no need. If it is more than 3 meters, usually at about every 2 meters or so, we provide an intermediate soil layer. So these are the photographs of construction occurring, and here you can see the red bajri, which has been put as the side earth cover, and then you can see a little bit of blue color in this photograph also. So this this was actually, this entire area was a water pond. So in this water pond, through the water pond, we had to construct our embankment. So in a waterlogged area, how do we construct our embankment? There are 2 ways. One is that we drain out that water, we remove the slush, and then we construct our embankment. Other is that if the ponded area is very large, and if you cannot drain out that water, what we do? We take this gravelly type material. We backed up our gravelly type material, and then after that gravelly type material has been backed, comes up above the level of water, we construct our normal embankment. So to back dump gravelly type material and to construct the embankment within the water, it will involve huge cost because gravelly type material is costly and a huge amount of wastage will be there when we back dump it, because it will not fall exactly the place we are intending. So it will spread out. So huge amount of wastage will be there. So the cost of back dumping the gravelly material within the water and then constructing the embankment over the water will be very huge. So unfortunately, in this particular instant, of course, we had no other option. This was the first case. So that is why we decided, okay, we'll go ahead with back dumping bajri within the water. Once the bajri level, red bajri, that is Mura level comes up above the water, we'll construct the flash embankment. So that was done, and it was it is in a very good shape. You can see in construction. Yeah, now, since that 1998, it was open to traffic and it is working very well. And of course, now it has been even more widened and everything. Now that Meerut Expressway is through that road only. This is another project, Dankuni to Kolaghat. It is in West Bengal. Few years after that one, and the length of the road and height of the embankment, etc., I have given. And here also, once again, the embankment has to be constructed through waterlogged area, and after pumping out the water, this embankment was constructed. And of course, this you can see white cloth here. This is the geotextile material, non-woven type geotextile material. It was used as a separator between the subsoil and the flash layer, which was laid above that subsoil. This geotextile is nothing but a polymeric material. Woven, the two types are there, woven and non-woven. This is a non-woven type material, which has been used as a separator. This is another project in Delhi itself, Kalindi bypass. Here also a flash was used for the embankment construction. And in this case, of course, also it was the embankment was constructed very near to the river. You can see the river, the water there in the first photograph. And since it was very close to water, the subsoil was slushy. Soft slushy subsoil was there up to 0.5 to 3 meter thick. If you construct an embankment over a soft slushy soil, what will happen? The settlements will be there. Huge amount of settlements will be there. Now we should prevent that kind of settlements, because we cannot afford to have our road. And if the settlements take place over within 1 month or 2 months, that's okay. We can go ahead with that. But the settlements will be spread over a few years, so that we cannot afford. So that's why we have to adopt what we call it as ground improvement technique. We have to improve our subsoil. So what do they do usually in such a kind of case is that they adopt what they call it as stone columns. So what are these stone columns? The stone columns are nothing but we make a borehole, take out that slush, backfill that borehole with graded aggregates, stone aggregates, compact it, and so it becomes a stone column. So several stone columns are laid out, and that it becomes a composite ground, and so its bearing capacity also increases. So in this manner, we eliminate or we reduce the settlement that is going to take place. Now that particular embankment was designed for the soil, and so stone columns were also proposed, and then it came to CRRI for review. Then we suggested that there is no need to use stone columns, there is no need to use soil, use fly ash. It's a lightweight material. Then if we use fly ash, the need for the stone columns can be eliminated. This, of course, this was we worked out. That's a particular case study also, and based on our calculations, we backed it up and we showed it to the Delhi PWD. The Delhi PWD also then agreed, and they went ahead with whatever the alternative design we had suggested with using fly ash, and this embankment was constructed using fly ash without any ground improvement, and so a lot of money was saved. This is another embankment, once again in Delhi, constructed nearer to Yamuna River, and this is the marginal Bund Road, MP Road, what they call it as. It's in East Delhi. And here also the existing embankment was there, so they were widening that embankment, and so the design is also similar. Then this you would have heard about this signature bridge in Delhi, which has been recently constructed. And this signature bridge, of course, it is also on Yamuna River. It's in Wazirabad area of the Delhi, and there also the approach embankments were constructed. They have used Flyash as the fill material. And here you can see that it's even more worse area because so much of waterlogging is there. So the embankment had to be constructed through this waterlogged area. If you remember this previous slides which I showed you with regard to Nizamuddin, at that time we had suggested, okay, use red bajri as the for back dumping and construct your embankment. But after a few years, this work was taken up, and at that time the red bajri had become even more scarce, even more costly. So using the red bajri for back dumping was totally ruled out. It was not available also. So what we should do? We investigated using pond ash itself. The pond ash is a non-cohesive material, and of course particle size may be smaller, but it's a non-cohesive material, non-plastic material also. So why not we back dump pond ash itself? So this was the idea, and so you can see that the back dumping of ash was done, and then of course when the level has come up, then normal type of embankment was constructed, and above that this embankment, even Ariwal has been constructed, and that is also so total of 10.3 meter height embankment is there. So the 10.3 meter of unreinforced, above that 6 meter height this Ariwal is also there. So that kind of a huge big structure has come up, but of course absolutely it is giving very good performance, very good satisfactory performance, and cement concrete pavement has been laid over that road. Not the bituminous pavement, but cement concrete pavement has been laid. Because the cement concrete, I'm stressing this point because if there are settlements, the cement concrete pavement will crack up very badly. Unlike flexible pavement, which can be easily repaired, cement concrete pavement cannot be repaired. But that's giving a very good serviceability. So these are some photographs of that Wazirabad embankment construction, compaction, etc. going on, and some tests being done, etc. And during that time, since so much of water was there, and we are back dumping our ash into the water, the doubts were raised as to how safe it is with regard to the this underground water, that is groundwater, will not get contaminated. Will the river will not get contaminated with heavy metals? So then we tested this ash samples also. We tested the riverbed soil also for different types of heavy metals, the copper, cadmium, etc. And BTPS means Badarpur Thermal Power Station, Rajghat Power Station, and so this is the soil, and you can see that the concentration of the different types of heavy metals in the ash is almost same as concentration of those heavy metals in soil. In some cases, you can see that even in the soil itself, the concentration is more than even the ash. And everywhere, maybe except this chromium, everywhere this it is much lesser than whatever that has been specified by the Ministry of Environment and Forest as the limit. And so how this is possible? This is possible because whatever the ash we are getting, it has not come from space. It has come from our Mother Earth only. So whatever the material is there in soil, similar type of materials you can expect in ash also. The concentration may be a little bit different. So we have to test the material. And once we are ensured that it's a safe material, definitely there should not be any problem in using that material. This is another case. This is from Gujarat. This Lakhpat is in Gujarat, near the Kutch area, and so this is from Panandro Power Station, which is once again a lignitic power plant, and this road was being constructed in the tidal area, very near to sea. This is the sea. Actually, in that tidal area, the high tides, the sea water comes few kilometers inside and then goes back when there is a low tide. During high tides, it comes in, and during low tides, it goes back. So that is why here there is no water. This is during high tides. So when that sea water comes during high tides, you would have seen that it doesn't come in a very soft and slow manner. It comes as a wall of water, and it hits the embankment. So there will be so much of wave action will be there. And this road embankment withstands that kind of an action. And of course, it has been provided with gabions and protective measures also. And yeah, I visited that same location after 6 years also. It is giving very good. This is after 6 years, so it is giving very good performance. This is during construction. This is 6 years after construction. And of course, during this was the type of location, the slushy soil, daldari, whatever we call it. So over which this road embankment has been constructed, and its performance has been perfectly good. This is one more embankment case study which I wanted to flag. This is also nearer to Delhi. You would have known that there's Delhi-Agra expressway is there, and now it is extended to Lucknow also. So before that expressway starts, we had this Noida expressway, Greater Noida expressway, and it is a 6-lane road. And for this road also they had used Flyash for construction. Actually, in a divided carriageway, the whatever the camber we have, it's not a bidirectional camber; it is a unidirectional camber. So unidirectional camber means the whatever the water, the runoff water is there, it flows towards one side, the one edge of that's the outer edge of the road pavement. Fine, that's okay. But the problem comes when these roads are located in a curved portion. Because in a curved portion, we have to provide super elevation. So the whatever the slopes are there in a normal road section in a straight length, so it will be sloping on both sides. But in a curved portion, it will be sloping on one side. So the entire water from the 6 lanes will be discharged on one side of the embankment. So that's what was happening here also in the curved portion. And unfortunately, they had not planned, they had not given proper treatment, proper curbs and shoots, etc., like that for that scenario. So what happened? So when there were heavy rains during the rainy season, so there was so much of water flow, and that rainwater, it eroded that cover soil, and once it reached the flash fill, the flash fill got eroded very badly, and so that's why you can see so much of failures are there, very severe failures are there. And then of course it was once again referred to CRRI, and we designed that shoots and curbstones, etc., whatever the remedial measures that were required, and these were implemented now. And now, since it has been almost 15 years now after this implementing these remedial measures, there has been absolutely no problem. Now coming to the reinforced fly ash embankments, all the case studies I told you, they were unreinforced. So reinforced fly ash embankment, that is what we call it as RE walls, reinforced earth walls. This of course is not exactly reinforced earth, this is reinforced fly ash. So use of reinforcement in backfill material is to improve its strength, is we call it as reinforced embankment. RE walls, as you would be aware, it's a composite material having 3 different elements: fascia panels, reinforcement, and a selected backfill material. Whatever the backfill material that is required for an RE wall, it must have a special some special properties, like it must be a permeable material, it must have a high phi value. This fly ash material, that is the pond ash and bottom ash, I told you that they do have high phi value and they do have very good permeability. So this fly ash is an ideal backfill material for RE wall construction. It's almost something which a designer can dream of, like RE wall designer can dream of. because it is having one more advantage also. The third advantage. That is the third advantage is that it is having a lower density also. So lower density means, of course, whatever the strength of the reinforcement that you are going to design, so that you can afford to have a lower strength reinforcement also. So all these important properties, advantages are available when we use fly ash as a backfill material in the RE wall construction. That is good permeability, lesser density, lesser compacted density, and third is that high phi value, high internal angle of internal friction. So all these properties, three properties, make the fly ash an ideal backfill material for reinforced earth wall construction. This is a case study which from Sarita Vihar we did, and you can see that RE wall being constructed, a fly ash being compacted. So this is the RE wall. You can see the reinforcement. They had used strips as the reinforcement, and we can use polymeric strips. We can use polymeric grades, any type of polymeric material. But of course, people are a little bit hesitant to use metallic reinforcement in this RE wall construction using fly ash. Anyway, now majority of this RE walls reinforced earth construction is done using polymeric material. Polymeric material is perfectly okay with fly ash. So this is and of course the compaction is going on here in this particular photograph. The details of that RE wall length, etc., that I have put it here. Now coming to few slides with regard to using a fly ash for road pavement construction. Of course, even before this, this Sarita Vihar embankment RE wall was constructed. Before that, we had constructed this Badarpur, this Okla flyover. So this Okla flyover was the very first project, and little because there the quantity of ash was used that was not much, and only one approach was constructed using fly ash, and that was in the year 1994. Almost same 1 or 2 years before this Nizamuddin embankment came, and Mr. K. Agarwal was the project in charge there. Now coming to the fly ash, using fly ash for the pavement construction, I have few slides. Fly ash is a better road construction material because it's non-plastic. It is having high CBR value and pozzolanic property. I already told you. Lignatic fly ashes have self-hardening property, means because they are having a little amount of lime. So along with water, they harden. But of course, to develop adequate strength, we need some more amount of cement also. It can be used for constructing a stabilized layer in the roller compacted concrete, in a fly ash admixed concrete pavement, or block pavement, self-fill concrete, etc. So many applications are possible when we go for a pavement construction using fly ash. Using it as a pozzolana in cement concrete, and I think other lecturers would have already covered it. I just have one slide. So this when we use fly ash for replacement as a pozzolanic material, what is a pozzolanic material? I have already told you. We can this pozzolanic property enables the fly ash to replace cement. Both anthracitic and lignatic fly ashes can be used, and we have a code 3812 part 1, which provides the property requirement for fly ash to be used as a pozzolanic material. The important point here is that the pond ash and bottom ash are not generally suitable for cement replacement. We'll have to use dry fly ash collected from the ESP for cement replacement, because once the ash comes in contact with water, it loses its reactivity. So once it loses its reactivity, we cannot use it as a cement replacement. So it will no longer be a pozzolanic material. That is why before mixing fly ash with water in a dry state itself, it should be collected pneumatically, and then we can use it as a cement replacement, and it has to be very fine grained also. More the fine grained, more will be the rate. But once we mix it with water, dump it in the ash pond, etc., then we cannot use that material for a cement replacement. But that material which is dumped in the ash ponds and bottom ash coarser material is ideal for our embankment construction. So in that manner we have to use it. Now, using ash in flash in cement concrete, so many advantages we get it in a green state as well as in a hardened state. The main advantage we get it is the improvement in durability, which I believe the other so many other presenters would also would have told you, and that's the main advantage. It becomes a durable concrete. This slide I have put it to just to show that how our codes vary when it comes to the percentage replacement of cement, because different codes tell us in a different manner, and of course it's up to the designer, it's up to the PAU to decide how much they can use. Now, if we see into this MORD specification, it says that you can use flash up to 30%. Flash cement replacement can be up to 30%. And if I see my MORTH specification, it says that you can be, it is more conservative. It says that you can use up to, you can replace up to 20%. Of course, either 30% or 20% is not as such, but it has to be done during the mixed design stage itself. That's and they have some limits for minimum cement contents also. What about IS 456? That is the IS code for the plain and reinforced concrete. So it says that you can replace up to 35%. So it is much more than this and this. And even in IRC also, this SP 68 is that is for the roller compacted concrete. It says that you can, in a roller compacted concrete, of course, the compaction process and all, it's different. The water quantity of water used also different, is very, very less. So that is why they say that you can go up to even 50% replacement also. So our different codes specify in a different manner. I don't know, some uniformity is not there, but anyway, we can within this codal provisions, we will have to plan. We will have to use a suitable. We can use a suitable amount of replacement. Now, one or two slides with regard to self-filled concrete and Kharenja. What is a self-filled concrete? You would have known that what is this block pavements. So the block pavements, we are all very well aware. We use it so many locations for footpaths, etc. like that. If you go to Bombay, so many roads are also paved with the block pavements. And the block pavements are made in the factory, brought to the site and assembled. But self-filled concrete is a block pavement which is made in situ. Self-filled concrete is a block pavement which is made in situ. So what do? We have the cells, and within the cell we fill the concrete, compact it, and that is left as it is. So the blocks are made in situ. So that's the self-filled concrete. We call it as self-filled concrete. And modulus of self-filled concrete is less than PQC. The plastic cells bend during concreting, leading to interlocking between the different cells. Just like what we have interlocking ICBP, interlocking concrete block pavement, the self-filled concrete is also interlocking, because when you put the concrete inside the cells and compact it, they bend, and so there is an interlocking. So how the cells look like that? The cells are like this. They are made from usually made from waste plastic, and this is the base layer which has been prepared for the self-filled concrete, and above that, of course, the side restraints are there. And this is the cells have been placed, and they are putting the concrete and compacting it. Compaction is done in the usual manner using a needle vibrator and a plate compactor like that. But of course, the issue is that this is a very time-consuming process, labor-intensive process. So that is why they adopt it for a rural road, where if it is a labor-intensive, they can employ more people, and even so that's a kind of a advantage they get. Kharenja, that is brick paving. So instead of self-filled concrete, you can go for brick paving also. So that can be fly ash, lime, gypsum brick blocks also, or fly ash plus cement blocks also. Normally, if we getting a good type of lime and gypsum is difficult, you can go for fly ash plus cement also. These points, of course, I have got it from Professor Dr. Kalidas from Visakhapatnam. So whatever the this Kharenja cost and all whatever he has told, and this, of course, I got it from Mr. K.S. Reddy of IIT Kharagpur. And then, of course, these photographs are from Karnataka Rural Road Development Agency. So these are some photographs of making block pavement and constructing beautiful roads using this Kadenja. This the if you watch this YouTube, you will it has all these photographs. Now using it for a stabilized pavement construction, just some slides. Mixing soil with mixing with soil reduces the plasticity of that soil. It's a non-plastic material, Flyash, so it reduces the plasticity of material which is mixed, and we can stabilize it using either lime or cement. Even bottom ash and pond ash can also be stabilized, but the strength gain with regard to the fly ash will be lesser because these are non-reactive materials, so the strength gain will be lesser. How do we mix that? Mixing is by using the rotavator for the rural roads. And so these are some attachments. Rotavator is an attachment which comes with the tractor. The main advantage what we get with the stabilized pavement is the reduction in pavement thickness, because the stabilized layers, they have a higher E value. I have put it here, higher E value. So that is why pavement of about 325 mm, which is which was earlier required, so that we can construct with stabilized layers using up to 275 mm. So there is a net reduction in of about 50 mm pavement layer thickness. This I have taken from IRCSP 72, special publication 72, which is a codal provision for rural road design. Same type of diagrams are there for highway design also, IRC 37. So the important issue is that since these materials have a higher E value, the thickness of the layers reduces, so the consumption of the material reduces. And this stabilized layer we can construct using a low-grade material like fly ash. So that is the biggest beauty. Some photographs constructing a stabilized layer in our campus itself as a test track using fly ash. So we are mixing it with a normal type of concrete mixer, then laying it and compacting it and like that. Of course, if you compact it using a roller, some amount of unevenness may be there. So we used a small roller to remove that unevenness. And once the stabilized layer has been laid and compacted, it has to be cured. So that curing is done by using wet gunny bags. So this is what you are seeing there. The curing process is going on. We don't cure the stabilized layer by water ponding, unlike cement concrete. So this is another very long back, more than 2 decades, and so this is a Raichur that's in Karnataka. I constructed this road. We constructed this road using stabilized material. We tried this lime stabilization. You can see the lime being stacked there, and all labor-based techniques were adopted for mixing, etc., the laying, etc., and of course compaction was done using the roller, and it gave very good performance. This is another case study. This was also in Karnataka, and once again a rural road wherein the stabilized layer was constructed. Stabilized fly ash layer was constructed using cement and this thing. And how much a quantity of cement was used, I have put it there. And this was used in the sub-base as well as the base course layer construction going on, the curing, initial curing before spreading the gunny bags. And after 1 year, I visited the same road. It is a perfectly, the performance is very good. Actually, it was being used as a rural housing colony road on which the trucks carrying construction material like bricks, etc., were playing. And so even then, you can see that it is in a very good shape. This is another rural road we constructed nearer to Delhi in UP, Western UP. Using a roller compacted concrete and a stabilized fly ash layer. Some photographs are there of laying the roller compacted concrete and then compaction using a normal roller. And of course, it was also a rural road, and so the performance was very good. Now, summing up, whatever the points I have told. So there are three types of ashes are there in the thermal power plant: fly ash, bottom ash, and pond ash. The fly ash is a very fine particulate size. bottom ash is a coarser one, and pond ash is a mixture of these two. The fly ash is a reactive material if we collect it in a dry state. Bottom ash and pond ash, they have been mixed with water, and so that is why they are non-reactive. Fly ash, we use it for as a replacement of cement, and bottom ash and pond ash, we use it for embankment construction. IRC specifications have been revised. Now there is ample scope for fly ash usage in the new specification through stabilization, etc. We can use this material as a fill material for stabilization and in cement concrete, and as a fill material and stabilization. Dry fly ash, which is as per the IS 3812 part 1, is reactive. You can replace a part of cement. Pond ash and bottom ash, they are non-reactive. We use it for embankment fill, and we can use it as a non-plastic material in the GSB layer also, in base course also. And we can stabilize the fly ash, we can stabilize bottom ash and pond ash also, and build our road pavement. Usage is environmentally safe, economical, and as per the government directive. And even the programs like Swachh Bharat Andolan, etc. Because we will be eliminating a huge dump of ash. If a dump is already there, we will be using it. And so we will be saving our conventional construction materials also. So this is that is why I have put it as environmentally safe, economical as per the government directives, and you can add one more point also, and sustainable construction practice. Thank you everyone for your patient hearing.
Thank you, Vittal Saab, for the comprehensive presentation and guiding us through all the case studies, major roads which we have constructed or which the nation has constructed using the ash, and explaining all the technicalities involved, why the soil coverage is required and everything. So participants may ask any queries. Vittal sir, some participants have written on the chat. If you may, just please.
Okay. So many good properties when compared to soil. Can we use fly ash for the fill basements of residential buildings and apartments instead of soil? Yes, exactly. Actually, and whatever the case studies I presented, it is for road works, but we do have used it as a fill material in the basement. It has been done, it has been tried, and it has given very good results also, because it's a non-plastic material, and whatever the settlements are there are very, very less. So just like it acts like a sand type material. So that is why even in this particular use also, whatever you have written, fill up basements and residential buildings, definitely it can be used, and it will be successful. That is my that's what I feel, and you can use it. Geotextiles, geofibers, and geosynthetics are plastic type materials or else. Actually, they are not exactly plastic materials. They are polymeric materials. There are so many polymers available: polypropylene, polyethylene, HDPE, like that. So these materials which you have put there, the textiles and other geosynthetics, it may be grade, it may be in the form of a strip, which I showed you. So these are all made using these polymeric materials. Different types of polymers are used. So plastic is also a polymer, once again, of course. Are we replacing tar with cement, but the increasing heat rate and the rubber tire of cement concrete is also a concern for things. So actually, we are not using tar, we are using bitumen. Actually, there can be a healthy competition between the bituminous roads and cement concrete roads. Actually, if we go for this bituminous roads, of course, definitely we have to import bitumen. That point is there. But the present government, it's giving stress on Atmanirbhar Bharat. So, but cement concrete roads, there is no need to import cement. All the cement we require, we produce. We are lucky in that aspect. So in that manner, then that's a good this thing. Of course, cement concrete road, if you construct, initial cost may be a little bit higher, but over a long range, the lifetime life of this cement concrete roads is much more when compared to the bituminous roads. So, and they also require very less maintenance also. So, in that manner, it is more advantageous. So, both of them, they have their own inherent advantages and some disadvantages also, which you have put it and like that. And, but of course, it's not that 100% will be either bituminous or 100% will be cement concrete like that. There will be a judicious mixing of this kind of these two type of payments. So, reinforced earth wall is a nailing technique. Actually, it is not a nailing technique. It is similar to the nailing technique. Actually, what is that soil nailing we do? Whenever already an embankment is there, already a slope is there, embankment is there, and if we want to improve the shear strength of that already built embankment at the slope, hill slope, or we insert nails and improve the shear strength of that particular slope. The reinforced earth is reverse of that. We don't have an embankment or the slope, but we construct it. So when we construct it, layer by layer, we put our reinforcement. So soil nailing is similar to reinforced earth, but the difference is that the nailing is putting reinforcement already in existing embankment or the existing slope. Soil reinforcement is building an embankment or building a slope using backfill material and the nails, backfill material and the reinforcement side by side, simultaneously. So, any other questions? Any other at this point? I think it is not there. Yes. Okay.
Yes, sir. Maybe close, sir?
Yeah, definitely. Okay. Thank you. Thank you very much.
Thank you so much. And it's so nice explanation. And I was just thinking that a seasoned man, how he explains, like you explained this question, nailing technique and reinforced earth difference. And definitely hats off to you, sir, and your rich experience. Thank you so much.
Thank you. Thank you all. Thank you all. I thank you, Agarwal sir, for giving me this opportunity, and I really enjoyed making this presentation. Thank you all. Bye.
Thank you. Thank you. So we close this session also, and tomorrow morning we assemble at around 10:20 a.m. Tomorrow we have Dr. Patelia's session also on the rural roads from 12 p.m. For PMJSY roads he will talk about. And in the morning session we have this Dr. Tilo Gupta ji, who will talk about stone processing waste in the concrete and their durability, mechanical properties, and of course about rubber crumbs also in concrete. So we meet again tomorrow morning at 10:20 a.m. All participants kindly join us tomorrow morning. Thank you. So I'm closing this session. Thank you all, sir.